Good morning. My name is Mike Carney, and this is the 13th of June, and we're in beautiful downtown St. Louis, having suffered through another Cardinal loss to Pittsburgh. And it's my pleasure this morning to interview Bill Chapman, past president of ASHRAE for the years 76 to 77, and an F. Paul Anderson Award winner in the year 1983. And Bill, it's my pleasure to have you here this morning, and we've been chatting a little bit prior to getting into this, and I think we ought to start your interview with a little bit about how you got into the air conditioning industry in the first place. You went to the University of California in Berkeley, I understand.
That's right, Mike. I was working at the time for a professor that was active in ASHVE, the old organization, one of the predecessor organizations of ASHRAE. And he was given a research contract with the Copper and Brass Research Institute to develop heat loss calculations and thermal balance in panel heating, as we called it then, where pipes were embedded in floors and ceilings. The problem was a very tedious problem, took a lot of time. We didn't have computers in those days, and so he needed several students to do this to get the job done in time, and I was able to get the work done by a shortcut technique that was completely valid, and apparently it impressed him. So when I graduated, he kept in touch with my wife. I'd met her at Berkeley, and he moved on to Purdue as a full professor. And when the war was over, he gave me a research fellowship to come back and continue in that same type of research. I did. I stayed at Purdue long enough to get my master's degree, but the research work still wasn't finished as far as it could go. Typical research, it almost goes on and on and on. You learn more problems than you solve. And I was interviewed by a group of engineers from U.S. Steel. They were interested in doing that work. And that was in '47. I went to work for U.S. Steel in February of '47.
Why were the steel companies interested in the
Well, they sold the pipe, and they wanted
a lot of pipe.
A lot of pipe. That was a marketing thing for them, and they first of all, they wanted to know if it was going to be practical. That later developed into snow melting, which was really the pioneer work that I did that I think led to the Paul Anderson Award that I got. So because of their research work, I elected to go with U.S. Steel. I was going to stay in the industry. I determined that because I realized there was a lot of engineering challenge. And in 1947, I joined ASHVE. That's been a while. But I've got a few years to go before I can claim to be a 50-year life member.
Well, you've got some good claims already. We know that. So you had your master's out of Purdue, and you went with U.S.
Steel, the National Tube Division of U.S. Steel.
Okay, and then when did you got involved in ASVE in 1947? ASHVE, I guess it was.
Yeah, there was
ASHVE, Heating and Ventilating Society.
Right.
And then you became involved working at the society level on technical committees.
Well, at that time, the society recognized that this was a new way of handling heat losses. And there were 4 panels set up, A, B, C, and D. And there were several important ASHRAE, I keep saying ASHRAE, excuse me, important society people involved with that. One was a later to be president, Ben Gordon, and my professor Hutchinson was interested in that. And these technical committees, we call them today, were set up to study different aspects. And because I was doing that kind of work, I was put on one of those panels. And my first panel assignment, or what we would call a committee assignment, was in 1948. And I'm really quite proud to say that I haven't broken that string since. I have had a society committee assignment now for 42 years. And that's
That's a mixed blessing, but a very much an honor and a distinguishing characteristic of
I
service.
wouldn't say it was mixed.
Yeah.
It's been time-consuming, it's true, but been very, very gratifying. There's a lot of satisfaction to contribute something, and I think when you do it on a volunteer basis, it adds to the feeling of satisfaction that you can get.
I think you're right. I think that's one of the remarkable things about ASHRAE as an organization. All the work is essentially volunteer.
Right.
And the results, when you walk through the bookstore, where the papers are on display just from this meeting, is really quite impressive. And when we realize all of this is volunteer.
Yes.
And any single thing doesn't strike you so hard, but when you look at the accumulated literature and the transactions and the journals and the guides, it's really quite.
And the scope of that work.
Yeah, the scope of it.
And you consider food technology and preservation and what that has done. Yes. The current impact of CFCs and what that means, and how the refrigeration industry will have to go back into the laboratories again and develop new refrigerants. Solar heating. Yes. By the way, my thesis at Purdue was on solar heating. So when the energy crunch came along in the 70s and gave ASHRAE a boost, it was also sort of a fulfillment, as it were, that the world is beginning to realize how important our energy sources are, and we should look beyond what we have done in the past and look to the future technology.
You were president during the time of, during the time of the, what we call as the energy crisis, or at least the heightened energy awareness in the 1970s. I guess technically the Arab embargo occurred in '74.
October '73, I think, was the embargo itself.
But your presidency in '76, '77 was very much involved in the reaction of our society and our industry to the heightened awareness of energy sources. You want to describe a little bit about that?
All right. Actually, ASHRAE had done most of its work prior to that. I was on ExCom, our executive committee. I was an officer, vice president, when we met in Los Angeles. And the Bureau of Standards presented to us some work that they had done and asked ASHRAE, we were ASHRAE by that time, it occurred in '59, to pick this up and develop a standard. We had the machinery for doing it, and we also had the prestige for doing that. Rod Kirkwood was president at that time at the presentation in Los Angeles, and it was just an earth-shaking requirement. We were stunned by the magnitude of the work that was to be done. But the government had been, Department of Interior, I remember the Secretary Morton, that had been warning the United States, and economists have been warning the United States since the late '60s, that we were more and more dependent upon others for our energy. Our energy sources are finite. A lot of work had been done in that respect. Our coal and our oil in the world now could be reduced to energy units called quads. Those are quadrillion BTUs as a quad. And the storage of that energy in the earth is measurable and frightening shallow. And I don't mean feet beneath the surface of the earth, but the storage bin is pretty close to empty in terms of what we would have imagined. That's been challenged by many, but I think most thinking people were aware of it, and ASHRAE probably represented, as a society, the greatest body of learned people to appreciate the seriousness of this. Consequently, we were certainly the one to write that standard. But standards take a long time to write, and the pressure to get this done, if we didn't do it, maybe a voluntary standard would not be developed. Maybe the government felt it was so critical that they would take it away and they would do it and force it, though that was abhorrent to the government people. They didn't want to do that either. So there was this challenge. We have to eat this elephant by noontime today because we got a big meal coming up later tonight. And that got us started, and we set up panels, and I no longer can remember the thousands upon thousands of hours and hundreds of people that got involved in different sections of writing those panels, and they were broken up into sections. A little bit later, maybe a year later, there was, it was under President Rickleton's term, a determination that the magnitude of the job was such we probably should simplify it, and we are more knowledgeable in energy conservation within the building walls, so let's not get involved with the resources themselves. Now, it was recognized that if we're speaking of energy conservation, and energy should really start with the source, the resources that we have, the oil and the gas and the coal, we would be restricting our efforts of writing a standard that was truly designed to preserve our fossil fuels to the fullest. But we felt that our expertise was such that we should limit it to the building walls. And I remember I voted for that. I remember wrestling with that concept. In a way it's not right, but in a way it's more practical. And I think we will be more credible to the world. They will accept our work, because everybody would have to admit that we do understand energy inside the building. But a year or so later, a short time later, Rickleton was bombarded with requests that this is too short-sighted. It's incomplete. We have to go further if indeed we're going to conserve and preserve our fossil fuels. So he set up a subcommittee, if you will, at first, to write something on what was then called Section 12. And those two men were Bill Code and Harry Phipps. Bill Code of St. Louis, by the way. Still active, very active in standards. Harry Phipps died several years ago. And they did present something. And to put it mildly, it was controversial.
That's not unusual.
Should we go out?
Code, I don't know
not
about
because
it.
true.
Bill Code calls it the way he sees it, and he sees it.
But there were elements that felt that we should remain inside the building wall, and there were other elements that felt, no, we should go out. So the election came to the board again, and I reversed myself. I voted to go the way we were in the first place, and regretted the fact that I had voted to restrict it to interior structure. That took a while, I guess, before Section 12 was ready to present something. And the other sections, 90.1 and such, were ready to go. And these were released, and we called it Standard 9075, if you recall. But the basic issue of whether or not we would be able to complete our work and go outside didn't really come to a critical point until I was president. And I'll never forget that meeting. It was in February of 1977 in Chicago. And the board meeting was on St. Valentine's Day, I believe. I remember certainly that the plenary session was St. Valentine's Day because I quoted Al Capone. And we just about had to take...
What did you quote from Mr. Capone?
Well, you can get an awful lot accomplished with a kind word and a smile, but an awful lot more with a gun. And there are times when you have to take strenuous efforts to make it go. So it was at that meeting that we did vote to reinforce our position that we would continue to study the total picture of energy resources. And it's a term that is, two terms in fact came from that, called riffs and roughs. resource impact factors and resource utilization factors. And they are no longer used. There was a very complex way to compare the energy that's used, how much energy is lost in transmission, what is the true impact of energy in the building on our resources that we have that have yet to be taken out of the soil, if you will. But at least that position reaffirmed that ASHRAE would stay with it and release the rest of Standard 90 so that it could go forward. I believe that Section 12 is now Standard 115. That's a number that you should check with staff. I think it's Standard 115. But without question, that was the most important part of my administration. You might say the last 6 months were anticlimax. But as presidents are, and to this day, they're interviewed when they go into the city, the press picks it up. I was always asked about energy. It was still a key issue, paramount in everybody's mind. It was newsworthy. We hadn't really resolved it. And the gasoline lines weren't as long as they had been a year or two before, but people were concerned about it. And now, frankly, I'm disturbed that that memory has slipped away. I talk to people, and there isn't the same awareness that our energy sources are limited.
Well, I think within our profession, there is very active awareness. But I think in the public mind, that's the difference. It has ceased to become a daily topic, and I don't think that. I think we're in the eye of the hurricane in that regard, and I think that's your point.
Right, exactly. Yes. The ASHRAE people have been lost. I used to speak at Rotaries, invited to go out and speak to the people, and there was an interested audience.
Yes.
Yeah.
Really, and still in that circle, I think Rotary is a very international, has a great international awareness, and I think in civic organizations like Rotary, the people who are aware internationally remain concerned about the energy consumption globally. Let me understand something for my edification here, Bill. The standard 90-75, the -75 means that it was put out in 75. Your administration was 76, 77. Are you saying that it was really approved and stamped as a standard? I know there's a lag somehow there.
Yeah,
but
that's
I'm not
right.
clear on that.
The time standards are reviewed, and they're put out for critical review, and before they can be released, they are temporary or tentative standards.
Okay.
But there were several sections of the standard that were going in. Standard 90.1, I believe. The 90-75 is what we think of as the first one that was released, and that was approved, but it wasn't complete. It didn't have all the sections that we knew would come later. There was another series, Standard 100, followed along on building renovations in existing structures, whereas Standard 90 was
new buildings.
For new buildings.
Yes.
In that sense, you're right that you can hardly speak of a standard of that scope as a standard. It is a series of standards, and they evolve and they go.
But it certainly, during the administration, it began to be public knowledge and on the street. I think that's what you're saying. And give us a feeling for the effect on ASHRAE of a standard that had such broad political ripple. I mean, we were impacting other organizations and other trades and crafts quite heavily.
Yeah, I can speak to that in two respects. Shortly after the embargo of October '73, the Wall Street Journal ran an article on the seriousness of this energy and the seriousness of our dependence on importing oil and what it could mean economically, as well as what it could mean to our comfort, what it could mean to the cost of doing business. It was so far-reaching. Energy is a very basic element in our economy, in the world for that matter. And it was an extensive article, a typical lead article in the journal. And though one or two of our members were quoted because they had worked in energy and were recognized as people that understood the impact, ASHRAE was not mentioned at all. And I spoke to one of those of our members that had been quoted, and he asked him why he didn't mention it. What an opportunity for us to get some publicity. He said that he had, but it was stricken because nobody would know what it was. Nobody would know that there was such an engineering society, and it was immaterial. The message was key, but who the group was, not so today. There is no lack of publicity today on what we have done.
Well, I don't know. I still think that in certain circles, ASHRAE is very well known. But I noticed that here in town, the Post-Dispatch hasn't picked up on the fact that this meeting is here. And I think there's too many issues. The issues of today, the CFC issue,
and Pittsburgh's in town.
Well, Pittsburgh, yeah, that hasn't helped. We've had a lot of trouble with that. Before we leave the issue of Standard 90, sort of describe a little bit some of the big political players. When ASHRAE put the standard on the street, there was a lot of political camps that became aware, certainly then, that there was an organization called ASHRAE.
Oh, yes.
And that the people involved with the refrigeration and comfort conditioning arts were making a statement about energy, and there was reaction. Tell us about some of the folks who were reacting to that.
Well, one, even in the design area, were the architects. They were very concerned that our standard would be prescriptive, that in their terminology meant that the standard would restrict their choice of design and what they might do. We argued that that was not the case. It really was not. We had a section 10 in the standard that allowed us to design an alternate system. And if the energy utilization of the alternate design was less than the primary design that followed what the architects would call a prescriptive design, it was acceptable, and it would be acceptable. Some of the examiners felt that it was so complex that how can we enforce this? Building
code inspectors, is that what you're telling me? Okay.
They had an influence. We had an ongoing, for 2 years after I left office, meeting with the architects and what they wanted to do. They wanted to get some research grants from the government and do some research and come up with standards of their own. They really didn't want to endorse this, and it was difficult. It caused conflict. I think the public would have been better served if the design professions would have had a united front and felt comfortable. But something of this magnitude is bound to develop different concepts, I shouldn't say bias in the sense that someone refuses to look at things in another way, but they have one view. They're looking at it in this direction, somebody's looking at it in another direction. It's hard to bring this together and show that it is of a common good. Much of that has passed with time, not because we don't have the same crisis today, but I think the understanding of how it can be done has been more comfortable. Then, of course, there were commercial interests. There was a pressure to the government through its agencies. The Federal Trade Commission wanted to impose restrictions that the refrigeration compressor in the home refrigerator would have to have certain energy requirements. And the question was, would the public buy it? Would the market be hurt? Well, obviously the manufacturers were very, very concerned. They had a tough choice between energy efficiency and marketability. Those issues had to be resolved. Many of those types of negotiable issues, if you will, took years to straighten out. And it went on without notice, really. And yet the Federal Trade Commission, you know, when they would have their own panels, consumer panels, as fellow Ralph Nader, there were to be consumers. And I remember at a hearing in Washington, well, I'm a consumer. I buy a household refrigerator. Well, but you don't count as a consumer. But I'm a consumer. You're not a woman. Well, that's true. I won't argue that issue.
Well, I want to get to your career with Johnson Service, but before we leave the offices and the format that ASHRAE has, I would like you to comment on ASHRAE as a forum for that kind of discussion, where you have strong political pressures coming to bear on an issue, a document that is going to have really an effect on how buildings are designed. The architects were right in that it's going to affect them. I think you make your point strongly, and I would agree that it wasn't a prescriptive code or standard. But when ASHRAE now publishes a standard, it has an effect, for sure. And now ASHRAE as a forum, the committee work that you've been involved in since, what, 1948? I mean, those committees are forums for sure, aren't they?
Yes, many of the committees, though, of course. When I first did committee work, it was at a very, very low level. It was purely technical. It would hardly be considered a forum. But committees like our handbook committees, where things are being published, they serve as references in the field of forensic engineering. If an architect or an engineer designs a structure and it doesn't work properly for whatever reason, if they can't show that it was designed in accordance with the guidelines that are set forth in ASHRAE publications, they have a more difficult chance to defend themselves. If, on the other hand, they can call up other expert witnesses and say, yes, this was designed as a prudent designer would do, there isn't an obvious fault, this is not a question of dereliction of duty or negligence.
He was following the practice of the time.
Right.
And I think that's one of the things that ASHRAE really does a good job of, is publishing our practice at this time.
And keeping it. So this time is always this time. Yes. We roll over our handbooks on a 4-year cycle now, and it's hard for technology and design practice to change much faster than that.
No.
But it's true. ASHRAE is a forum, and it is made up of people that, to put it crudely, don't have an axe to grind. We're a 501c3. We don't lobby. We can appear before legislators, city, county, state, federal, and as technical professional people, we're not there to lobby. We're there to give our advice and our opinions. It's one of the loftier aspects of ASHRAE. Not many people recognize that.
It's an interesting society from that respect, and a rewarding society. Tell us a little bit about your work with Johnson Control, and we haven't mentioned that yet, but you came out of when we left your career, you were going with
U.S. Steel.
U.S. Steel, and so somehow we got to Johnson, so I want to get into that a little bit.
All right. As I said, I became a member, and I wanted to stay in the industry. The work that I was doing with U.S. Steel, the research work, I was able to finish up most of what my first assignments by the time I'd been there 4 years. And then I wanted to take it out into the field to the designers so that it would be used. There was no point in just writing papers. In the meantime, an interest was being developed on snow melting, where you'd melt the ice and snow in front of emergency places, hospitals, firehouses, toll plazas, and such things as that. So it was the same thing. Coils were embedded in concrete, but it was outside as opposed to being in a building. We were handling materials that wouldn't freeze when it was turned off. It was considerably different. And I'm quite proud of the fact that I wrote the first chapter. I developed the equations that allows you to design a snow melting system purely on a rational basis. And that is still published in today's handbooks, and I did that work in 1953, I think, when it was first published. I think that's what led to the award of the F. Paul Anderson Medal that I got later.
Why don't you describe that a little bit? And describe what the purpose of the F. Paul Anderson Award is within ASHRAE. I think that's
the F. Paul Anderson Medal is ASHRAE's highest award, and it's granted for achievement, meritorious service in technical field. You have to make a contribution to the knowledge of engineering of our field, as opposed to the Distinguished Service Award that you provide meritorious service, but on committee work, and which is purely service.
Yeah.
The F. Paul Anderson Award, you might say, is the award just above a fellow. You're granted a fellow for work of technical achievement. And the reason I might be unduly proud of the medal
justifiably proud, let us say.
Thank you. I feel that professional people, like engineers, have 4 responsibilities. First, of course, is responsibility to yourself. If you don't have self-esteem, you're not going to be able to do much for anybody else. And your second responsibility is to your family. You start that with your brothers and sisters just as a toddler. You do have a responsibility to your family, to be a good family member. And then as you get older and you get married and you have children, the responsibility changes. Nonetheless, it's a family responsibility. Then your next responsibility is to your community. So you can do that through PTAs or Boy Scouts or school boards or village trustee, or any of a number of things. You nonetheless owe something to your community. But the fourth responsibility is to your profession. And if you fulfill that responsibility, then you're also fulfilling your responsibility to your employer. But that's hard to measure. Have you really done something for your profession? Have you really filled in a little grain of sand in that canyon of ignorance, or is it all fluff? But when you're given an award like the F. Paul Anderson Award, there's a peer recognition. Your fellow engineers agree that you have done something worthwhile. So
yes.
So it was my fourth accomplishment. And
well, I think I would certainly think your pride is justified in that. I think it is the highest award of the society, and it only can be given to one person a year, and everybody in the audience, when it's given, takes pride in that recipient at that time. I think that's just an exciting time with them.
Oh, it is, and we try to, that's another thing that ASHRAE does quite well. We give our honors, and we try to bring people up for their moment of the limelight, as it were, and so that they're recognized for what they've done.
We mentioned earlier that there is only one president, and after you've been president, you're no longer the president, but once having received the F. Paul Anderson Award, you have always received that.
That's true.
That stays with you.
That's true. You can wear your ribbons forever. But, speaking of the presidency, I remember when I retired as president in '77, I was talking to our industrial psychologist at Johnson Controls, and as I didn't realize this, but I really think my experience with ASHRAE has added one other thing. I have been given some experience in retiring. You're president of ASHRAE and dealing with something of, honestly, national importance, really big issues, none of this make busy kind of stuff that you frequently have to do. And then the day that you turn over the gavel, you drop to vice chairman of the nominating committee. Which is
precipitous.
Where? What happened to him? But you adjust to what some people find difficult when they retire, in that they're not needed anymore. And that's really a psychological threat to stepping away, and becomes frightening. Really, really frightening to some people. That, gosh, if I'm not needed, what am I doing around here? You know? And I did notice that I really then started preparing for retirement, and I retired in January of '85. And speaking of volunteering, I'm the volunteer director of the Science Museum in Milwaukee.
Oh, is that right?
Yeah, and it's an 8 to 5 job. I spend that full time going in there until we can raise enough money to hire somebody.
Well, that's a very interesting thing.
This problem we're trying to hit is this science illiteracy. Math and science education in the United States is abysmal.
Abysmal.
And
it's
recognize it as a problem, so I thought, well, getting involved with the Science Museum, we can really go after that problem and do something significant.
Let me digress and do a little politicking here, if I may. In our historical committee meeting here in St. Louis, one of the line items for investigation is, what does it take to create a museum or a archive of the refrigeration and comfort conditioning arts? There is no dedicated place as such that has a national stature. Our profession creates economies. I've got documentation in my portfolio there from New Zealand that had virtually no economy until a refrigerated ship in the year 1778 brought sheep's carcasses on a 90-day voyage to London and sold them at a profit. And all of a sudden, that great land of New Zealand was able to raise considerably.
Just by packing them in ice.
Yeah, well, no, they had a refrigeration plant on board.
In what year?
In the year 1778. It was the refrigerant was air. It's a remarkable apparatus. And it wasn't the first. It wasn't the first, but that's the point I was making. Refrigeration, mechanical refrigeration, has literally made the economy of a country called New Zealand. Now, when you take that kind of an impact, certainly on the New Zealand people, everybody here in this country has been impacted by the ability to use refrigeration and cooling throughout their life. And there is no repository for the archives of men and women and the machinery to do that. In our little committee, we're trying to figure out, all right, how would you go about this? How would you do that? How would you put people together? Patrick and I were in a museum. No, Patrick wasn't there, but I was in a museum in Seattle that is for aircraft. And a very nicely maintained building. And of course, aircraft are big. You know, we think air conditioning stuff is big, but aircraft are certainly big. They're hard to collect, and they're doing it. I think it would hurt my feelings if we get to our centennial in 1994 and haven't at least started that sort of thing.
Well, I do know that museums can be self-sufficient. You have one right here in St. Louis, the Magic House. There are no funds from the city, the county, the state. They have a relatively small list of members. They're essentially living by their admission fees. They don't have a gift shop, and they have, being the director of the museum in Milwaukee, every time I go somewhere, I take a postman's holiday, you know, and walk into the museums. You have a very fine science museum in Forest Park. But this Magic House...
Have you been to the Transportation Museum?
No, no.
Well, do tell me about the Magic House, and then I'll tell you about the
is
Transportation
closer.
Museum.
Strictly speaking, the Magic House is a children's museum as opposed to a science museum. But the point I'm trying to make is, it's not at all inconceivable that ASHRAE in Atlanta, next to its headquarters, it could acquire property and establish a museum and charge admission fees, and if it's done cleverly so that the exhibits are presented in an entertaining fashion, that is what I have learned.
Yeah.
People will come in to have fun and enjoy it, and it wouldn't just be our membership.
No. And learning can be fun.
Indeed,
It can be exciting.
Absolutely.
That's an interesting idea, because Georgia Tech is right there. I think that whatever is established needs to be a teaching vehicle also, not just for the general public, but for people who are in the front line of research at that time.
And that's education in its broadest sense. It's obvious.
Yes.
It's there to show progress and why, and the relationship of one thing to another, why this was successful and why this wasn't.
Yes.
It is entertaining. It is true, I will admit, that people will take their children to a museum or their grandchildren to a museum more often than they will go to a museum alone.
That's
So
interesting.
there is something, because they want to help their children acquire an education. They feel they have that education, so there's that added incentive. And that in turn puts a little different slant on how it is entertaining, why it's entertaining. It's always fun to be fooled, you know, but it's even more fun to know how it was done. So you can put things in sort of a magic...
Where is this Magic Museum? I don't
516 South Kirkland.
516 South Kirkland.
Now talk about politics and a plug.
Well, that's a good plug for that. The Transportation Museum is out in Creve Coeur, and it's a collection of railroad
They also
engines
take
and
space.
train, and that takes space, and bless their hearts, they're sitting out there in the open, and volunteers, here again, volunteers,
Right.
are maintaining them and restoring them, and trying desperately to save that heritage for generations to come. But it's a tough challenge, but it's there. It's acres of railroad cars. Now, you have a list of points that you were hoping that we would make in this little interview, and I don't want to miss any of those particularly, but how are we doing on your list? And
well, we're doing quite well, because without question, Standard 90 was... I can't think of anything that was in second place. And we spent quite a bit of time on that. You asked me how I got with Johnson Controls, and my wife always accuses me, when you ask me a question, be careful. What time is it? And I'll tell you how to build a clock. And I have strayed, every time you've asked me that, I've strayed onto something else. But I had been active in ASHRAE again, and the branch manager, in those days called Johnson Service Company, was also a very active ASHRAE person. And he asked me if I'd be interested in becoming Director of Research for Johnson Service Company. And I said I'd be delighted to do that. Well, I was interviewed and obviously got the job in 1956, and I moved from Pittsburgh to Milwaukee and became Director of Research and then Vice President of Operations, and then retired in '85. But that was the route, and I never did get back to California except for visits.
Well, your peers and your superiors at Johnson Control, were they supportive of your work in ASHRAE, or how did they view all this committee work?
A president, in fact, the man that was president when I was hired had been active in ASHRAE, and he knew how much time it took. So we did have a corporate policy that you could not get on the board of directors. You could not take a job of that level. You could take any of a number of committee assignments. So he retired, and then his successor came in, was not quite as stringent on in that respect. And then when he retired, our president, who just recently retired, had been in the sales department, and he felt that ASHRAE had lots and lots of members in all of our branch offices. We had, at least the branch manager was a member of ASHRAE. So he felt that it would be a very worthwhile thing, and he changed the rules. So I was then allowed to go on, and I went on the board of directors in 1969.
Well, that started your walk through the chairs then.
That started.
You got involved in that at that level.
Yeah, then I got into XCOM in '71. And,
well, it's been a rewarding walk for you, I'm sure.
In fact, there's another bit of advice, one of the unknown things about this. I used to speak to my young managers to get active, not necessarily ASHRAE. Being in research, we had people over in IEEE and ASME and a number of different organizations. You learn something in dealing in a society through committee work that very, very hard to learn as an employee, where everybody's an employee of the company, and you're bringing diverse ideas into a group with consistent policies and purposes, but they're coming at it from a different angle. And obviously, you have to be persuasive. If you can't get someone else to accept your idea, it's not going anyplace, of course. And that training, I think, is valuable. In committee work, it's challenged, it's maligned, it's ridiculed, but there is no form of communication comparable to a committee meeting.
That's right, and at least they made the camel eventually.
Yes, absolutely.
They got the camel out.
Sure, and we wouldn't have had a camel if it hadn't been committees.
Okay, do we need to stop for that replacement, or what's your plan?
No, the mic came unplugged during the thing, so you can keep going.
Okay.
I can go ahead and dub down.
All right. I think it's time, Bill, that we let you take a look in your crystal ball from your experience and give you an opportunity to say what you see coming up, the challenges for either ASHRAE or our industry ahead. What kind of issues do you think we're going to be faced with and need to address as we go ahead?
All right. It's rather obvious, I believe, that computer technology is moving into all aspects of industry. And that's going to be a significant advantage in energy conservation. The ability to program, to pick up information, digest it, and put it back out for the operating engineer to use is picking up leaps and bounds. One of the first symposiums that I organized was in 1958. It was when ASH, in 58 we were AE, that was in 55, had a laboratory in Cleveland. And I was concerned about control systems working together they have different response times. Larger systems take longer to come up to a new level of output, and smaller, lighter things. And matching the equipment with the structure and the need of the structure. Like a Monday morning warm-up in the wintertime, people come in, the building has to be warm, has been cut back all over.
Would this be called system dynamics?
System dynamics, right. And the point was brought out by a man who had been in ASHRAE a little longer than I, that later became a president, that even if we had this research data, what in the world would we do with it? And I admitted, I had to acknowledge that I really don't know how we would digest it, but I don't think that's particularly significant at this time, because it's going to take us a long time to get all of these transient characteristics together, and we're going to have to get the different manufacturers to realize that system dynamics will be important to us. In the meantime, we will find a way to use the data. Man has never had a bundle of information and wasted it. Well, I lost. I hadn't had enough committee experience. He was too clever for me. So nothing came of that meeting except a bill for the railroad. But later, we were starting to gain on that. We were beginning to learn more about computers. And I established a task group while I was in office. I now had a little bit more influence than I did in 1958. So in 1977, I established a task force, and it was on system dynamics, which is now a TC. It has grown to that. And it's an accepted fact, and we are progressing in this. But what this means, and what I feel will happen in the future, that instead of computers being an adjunct to a control loop and just feeding information back, we will use a technique that uses a horrible name. It's called artificial intelligence. And I think that's knowledge engineering is another phrase that's used for it. I can't understand how intelligence could be artificial, but it's a phrase that people seem to recognize at least. The information can be picked up continually from literally hundreds of points throughout a structure. And as the trend from normal conditions to abnormal conditions developed, this information can be fed in. And I'm not speaking of self-adaptive systems at all. I'm speaking of true application of this knowledge. A solution to the problem will be presented to the operating engineer. When you think a minute, if anybody is in charge of running something and a light comes on, a red light comes on, you have been trained and you can describe what it is you're supposed to do when this abnormality develops. If you can explain it and you're articulate, you can program it. If you can program it, you can put it into the computer and it will do the same thing for you. And just as a computer can be trained to play chess. I'm probably getting a little too technical now, but before we had computer-controlled systems, and this was, Johnson put out his first system about 1960, 61, somewhere in there. We wired things. If we wanted a thermostat to control a valve that was electric, we would run a wire to it. If it was a pneumatic thermostat, we ran a tube to it. And things were physically connected for a given design. And as the building changed and as the functions changed, these hard-wired things, as we call them, became an obstacle, an expensive thing to change. We then learned later that if we could do this and you could rewrite the program and re-instruct the control system as to the new environment it was to control or monitor, it was no longer hardwired. You could do it with software, not wire, software. Well, the same is true with artificial intelligence. The building will react because anybody that is there will make the same diagnosis given the information. The difference is that it might take 1,000 points of information and that will overwhelm the operating engineer and he can't handle it. Yes. It will not be a problem. When I retired, the cost of that kind of a system was prohibitive. It did not have a payback. It could be done, and we would put up little systems in the lab that would perform, so we knew the process was correct. But the marketability wasn't there because of the prohibitive cost. You weren't saving enough to justify such an expense. So we, in a sense, we have to wait for it. The irony is now that the man that won the argument in 1958, shoes on the other foot. We now can handle the data, and we don't have enough of the data to plug in. But there has been a lot of research, transient analysis, dynamic response, has been going on, and we've gained a tremendous amount of information. But I see that as a significantly different
That's
approach to the operation of a building.
an important frontier.
Right.
The dynamic of the building itself.
Right.
Is a
That's like night and day.
Yes.
Everything has been done in a static fashion.
Yeah.
And just think for a minute, you're familiar with the comfort zone. We have the wet bulb and dry bulb temperatures
Yes.
form sort of a rectangle on a psychrometric chart. We have learned that the occupants can allow that temperature to drift about 1 degree an hour and really not recognize the fact, closer to 2 degrees really, but certainly 1 degree an hour, not realize that it's a little bit warmer now than when you first came into the room. You're just as comfortable because your body has adjusted to it. So it immediately comes to mind, well, the thing to do is we'll pre-cool this little guy, this building, this room. So when people come in at first, it might take them a few minutes to feel that it's a little bit too cool, but they're used to it. And we'll let that thing drift through the zone, and it'll be 1 or 2 degrees outside the comfort zone, just about quitting time. Now, there's no way you can do that. You're literally adjusting the thermostat in that room every few minutes. It would be absurd. But we can do that with a computer type of a control system.
It's going to be an exciting world.
Oh, yeah.
It is an exciting world.
It is one.
It is an exciting world. And I'm glad to be part of it with you and be part of this opportunity to interview you, Bill. And do you have any points you'd like to make before we close? And if so?
No, I can't think of anything. I was relying on you to prime the pump, as it were. You've done a very good job of that, Mike. It's been fun talking to you.
Well, I appreciate this opportunity. We are doing this, as I mentioned to you, as part of just to preserve the heritage of the leaders of the society and the leaders of the industry. And I thank you for taking time here in St. Louis to do that. And I want to try to look up the Magic House, and you might try to see the Museum of Transportation sometime here, and we'll probably have a chance to chat a little bit
I
about
did see your science museum the ones I said.
It's a good museum. We've got several nice places like that in St. Louis, and I think ASHRAE needs and deserves an equal place, and maybe we'll get a chance to talk about that
Okay.
in a future date. Thank you very much, Bill Chapman. Appreciate you taking your time to do this.
I enjoyed it very much, Mike. I really did. Good.
Okay. Now, techies, do you have anything you need from us? Do you need any shots of anything?
You said it would take about an hour and a half.